We're going to go through the lab assigned today. You do have a lab due tonight, right? Okay, good. So one more lab for today. From my experience, this will be your hardest lab.
The first part I got down easy.
Of this lab?
Yeah.
Good.
The second
Is
part.
that paper due next Tuesday, the same day as this lab?
What
When is
paper?
that due?
He hasn't signed it.
I haven't assigned it yet.
Okay.
All right, this will probably be your hardest lab.
Oh.
Not lab 7.
Um,
No, lab 7 is not that bad. This one will probably be your hardest one because you have to really sit down and think about how do lists work, how do sets work, how do you combine them together. So please do give yourself some extra time. I wanted to do this one earlier so when it comes to the end of the semester you're not pulling your hair out trying to do hard labs. All right.
too late.
It's not there yet. So create a class called listUtils that contains a function elements less than that takes the, not a linked list, just a list. I'll have to fix that. And a comparable. And it returns a list. Notice returning a list that contains all the elements in the linked list or the list that are less than the comparable. I've given you a quick stub to start from. Basically, you're going to run through the list I pass you with a bunch of comparables. With the comparable I will pass to you as well. And you need to return a list of all the elements that are less than the comparable. Did you see what I did there? Do you understand what's going on?
Return a list of items as less than the comparable.
Mm-hmm.
So that means we need to use that last one you showed us. That only takes the single out of it. It has no doubles. Is that what you're saying?
No, this is working with only lists. There's no sets here.
Oh.
Elements less than. So a comparable C means that you can compare it against an element inside of list. So for every element inside of list, you can do C.compare2 because C is comparable. C.compare2 and return, and that'll return an integer representing if it's less than, equal to, or greater than. If the element is greater than the comparable, meaning that it's less than, then you want to add it to that list ret and then return ret. So you got to really think about these interfaces here. The reason this one is hard is I've only passed you interfaces. I'm asking you to return a list, which is an interface. It could be a linked list or an array list. I have a linked list right now. I'm giving you a list, which again could be a list of anything. It also contains any type of item. And then a comparable, which I haven't told you exactly what it is, but what I've told you about it is that you can compare it to each element of the list. So this is really just to narrow down that, hey, look, this is really just to solidify the dependency inversion principle. That I don't have to tell you if it's a linked list or not. I don't have to even tell you what the items of a linked list are for you to write this function. You can just write it, and then later on you can call it with whatever elements you have. Any questions about this one? So this one can be a little hard to read. Of course, you can ask me more questions later. All right. Part 2, you'll be given many xy points and then asked if a point exists. This one will probably take you a while to figure out how to set up a set properly. Your class should have add point, where I give you an xy and it adds a point to your point model. And I need to load API.pdf, and then point exists, which tells me if that point exists in your point model. Ooh. Lab 08 API.pdf. By the way, I coded the solutions to these, all except for the last extra credit are less than 10 lines. You really have to just think about what you need to call. Some of them are only 3 lines is the solution. But the trick is thinking about exactly what's going on. So with part 2, you'll have your print model, where it adds a point to the your collection of points, and point exists returns if a point has been added to the point model. So this only returns true if earlier I've added the point. Okay? That's all it does. I'm giving you a hint. I create an inner class called point that represents a point of xy. And I'll let you think about how might you create an inner class called point to solve this problem, to help you solve this problem. Because if you do that, then those two functions are one-liners. All right, part 3, create a hash table util class that contains a static function remove duplicates that removes all duplicates that are in an array. For example, remove duplicates of 1, 2, 3, 4, 5, 2, 3, 4 should just give you back 1, 2, 3, 4, 5. For your convenience, I've written you a heading below. So you can see the API for details. Here's a big hint, use a hash set. Why would you want to use a hash set? Remove the duplicates. All right, there you go. Okay. So those probably sound pretty hard. Do they, or not so much? Good. So here's some extra credit. And this will really give you an idea of what's coming up in data structures, or if you take my competitive programming, what's coming up. Because we'll talk about how to solve these extra credit problems really fast. We will. Again, for the 2 extra credits, you don't need to do them to get 100. These are just to help you think about whether you want to, which path along computer science you want to go. So in the same hash table util class, create a static function sum pairs that returns the number of pair of integers in the array that's summed to sum. Okay? So if you have 3, 5, 8, 0, 1, 4, how many pairs sum to 9? Well, 2 of them, namely 5 and 4 and 8 and 1. 3 and 5 don't, 3 and 8 don't, 3 and 0 don't, 3 and 1 don't, 3 and 4 don't. 5 and 8 don't, 5 and 0 don't, 5 and 1 don't, but 5 and 4 do, so that's 1. 8 and 0 don't, 8 and 1 does, so that's 2. 8 and 4 don't. 0 and 1 don't, 0 and 4 don't, and then 1 and 4 don't, so there are 2. See what I did there? All right. This last one is actually very, very hard. Fair warning. This one's hard. Create a class hash string matching that contains a function index of string and match. That first determines if the string match is contained in str. That's actually all it does. And it returns the index of match inside of str. If so, then the function, it returns the starting index of the match. So hash string of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 4, 5, 6 should be 3 because it starts at index 3. That doesn't sound hard, but your naive approach will completely time out.
Sounds like something I'll do.
The big hint, let's see, full timeout. My solution does not use a hash table but involves hashing and solves this real fast. So I'll let you think about how that might be able to solve that. All right, you're in charge of manual testing. Push up to GitHub. It's due a week from today, technically. Although those extra credits are worth, I think, 25 points each. So if you turned it in late, you could still get over 100 if you did the extra credit. But please don't rely on that. You will. Those two are a lot harder than the other ones. All right, any other questions? Nothing? All right, great.
What lab number is that? 8?
8.
So you have one more after that?
I probably have 2 more. 2 more labs. And then usually I do about 10 labs in this class. 10 labs, ethics paper, and a final project. Yeah, it's not that bad. What?
Oh, no.
It's data structure. I think I just assigned lab 20. Yeah, lab 20.
There's one day every day?
And data structures?
Yeah.
Yeah, I assign one every day. Sometimes I assign 2.
Do you do that so people retain all the information, or because you like to torture?
There's just literally that much stuff to go through. It's a combination of there's that much stuff to go through, and I need to get it's coming of age where we need to get you into like spitting out code really fast. Yeah. And accurate. The labs, though, I would say are not as quite as involved as this, coding wise, but they make you think a lot more. Actually, this lab is probably a perfect example of what they're like most of the time. Because it's once you understand what's going on, it's straightforward.
Not a lot of lines of code, but gotta.
Yeah, you gotta really understand what's going on. Otherwise, you're only gonna only sadness will occur.
Turmoil.
Yeah, turmoil. All right. That's all for today. There's still about 50 minutes, so please go and get started. Make sure you get your design documentation done and start working on your implementation for your project.